Hello, Rishi. Shall we start the session?
Yes,
Yeah.
sir. We shall start now. Good evening to everyone. I'm Rishi and I'm the anchor for today's event. On this fine evening, I'm happy to announce that we are conducting the 7th day of our 14-day online internship program. The topic for today's session is virtual reality and augmented reality. And the speaker is Mr. Brijesh Kumar Tippi. Please post your questions, if any, in the comment section of our YouTube channel. Before starting the session, I shall give an introduction about the speaker. Shri Brijesh Kumar Tippi is a dynamic professional developer cum programmer with 14 plus years of experience in gaming and edtech industry, with development on Android, Unity 3D, Java, J2ME, BlackBerry platforms for Jamdat Mobile Incorporation, Electronic Arts Incorporation, Dhruva Interactive Private Limited, and Image Infotainment Private Limited. He has completed his MCA Nazat College of Computers, Osmania University, Hyderabad, and BCA from Hyderabad Degree College, Osmania University, Hyderabad. Brijesh Kumar has completed over 12 projects in different organizations for different clients and played the role of developer and game programmer in the projects. Shri Brijesh Kumar has very vast knowledge and experience on Android development for research and development on Android platform for development of EA products, platform conversion from J2ME to Android, Java for EASDK and non-EASDK based games. He also has working experience on Unity 3D development, J2ME platform, and EdTech development. Shri Brijesh Kumar has vast knowledge of different programming languages like Java, C Sharp, C, and C++, and has good understanding of mobile technologies, graphics technologies, IDE tools, bug tracking tools, version control tools, etc. Shri Brijesh Kumar has worked on development, deployment, debugging, and unit testing of more than 60 to 70 EA game titles for hundreds of different devices for different regions and languages on Android, J2ME, and BlackBerry platforms. Now, sir, I request you to take on the meeting, sir.
Hello. Yeah, so good evening, everybody. Thank you, Rishi, for the introduction. Is the audio clear? Should I start sharing my screen?
Yes, sir, you can start, sir. Clear.
Yes, thank you. Okay, so this is Brijesh. Good evening again. Today we are here to talk about this technologies called AR and VR technologies. The webinar is all about AR and VR technologies, and we are going to learn about what these technologies are and how these technologies are basically termed as future technologies and how they are transforming the way we actually interact with technology. And also, like when I talk about AR and VR, I'm going to relate these technologies more with computing. And when I say computing, we're going to understand how these things are relating to computing. But basically, these are the future technologies they are generally called as. So let us see like what these technologies are and try to understand each of these technologies. There are a lot of abbreviations relating to these technologies, like it is called as AR and VR. and MR and XR. There are a lot of abbreviations relating to these technologies. So let us try to uncover these technologies. What are they? Okay, so before proceeding further, like what all things are we going to discuss? What are the things we are going to cover in this? Let's just see what the agenda is. And so we'll start with some history of these technologies, like what is augmented virtual realities and all, and when did these all things started. Okay, since 1960s, 70s, and all. So we'll see that, and then next we go to the future of the wearable devices. Okay, once we see the history, then we go to the.
Sir, sorry to interrupt, sir. Kindly put in full screen mode, sir.
Okay, I'll try to open it in Office. I guess this is Liber. Okay. Oh no, wait. Yes. Is full screen now? Yes. Now everyone can see, right?
Yes, sir. Okay, sir.
Okay. So let us talk about the agenda, like what all things are we going to cover is the brief history of these technologies, and then we'll go and see what is the future of these technologies, how these technologies are building up, and how they are transforming the world. And next, we'll see in detail about each of these technologies, understanding and exploring what is augmented reality. And then we'll try to explore more details about virtual reality, okay, how they are different from each other. And then we'll also take one more step to understand there's one more thing called MR, mixed reality. And that is basically like the advanced version or the technology which is basically combination of both AR and VR. Okay, so that one we'll see next, and then we'll go and explore about their applicabilities, their applications in different industries, how these technologies are adapted by different industries. Okay, then we'll see some statistics relating to these technologies and their markets, how they are growing and how people are adapting worldwide, industry wide, and consumer wise, how they are adapting. And then we'll also see finally the closing Q&A. Okay, so let's start with some history, and then there is this first thing I want to show, like when we are talking about AR, augmented reality, VR, virtual reality, and MR, mixed reality, it is called as. So all these basically are termed as reality. Okay, and the person who actually started in terms of history, if we talk about Steven Sutherland, he has this quote like, a display connected to a digital computer gives us a chance to gain familiarity with concepts not realized in the physical world. So there are some things that we generally cannot experience in real life, or it is hard to actually explore or experience that in real life, but can be made possible in a virtual world, virtual life. So this is, it is like looking glass. It is like a looking glass into a mathematical world. Okay, so we'll try to explore what he's trying to say. Okay, so he's actually trying to say like what we generally experience as reality, everything that we see through our eyes and ears and our sensors is the reality around us that we can touch and feel and hear and everything. But now think of the world that is not just around you, but think of creating a world which is similar to reality, and that world is created using computer. Okay, and now you think like you are inside that virtual world, away from the physical world. So how can you actually teleport yourself from the real world into a completely virtual world where you look around, you see a different world which is not reality, and you can actually interact with objects in those virtual environments. You can walk, you can talk, you can interact, you can do a lot of things what you generally can do in real life can mostly be done in virtual environment. So that is what he's trying to say. So this is the guy who actually started this exploration of technology, like going beyond reality and adding some extra information that basically reality cannot provide. So he started with this kind of a headset like in 1968 along with a student and created the first virtual reality head mounted display, HMD. Okay. And named it as Ford of Democles. Okay. So before going to exploring all these, the future technologies, in the past, people have gone beyond creating the headset that we have just now talked about was actually the initial experimentations that people have done. Then the more rigid kind of industry adapted kind of a mechanism or system basically, which was actually called as cave automatic virtual environment. Okay, so this is basically the kind of system which allow people to build virtual environments and make people to walk around or navigate through those virtual environments in a natural way, like the way we generally walk or talk or move around in real world. In a similar way, we wanted to have that kind of a natural interactions, natural movement in the virtual world also. So you create virtual world using graphics, and then you want to navigate by walking. You want to interact with objects using your hand instead of keyboard or mouse. Okay, so that is where this kind of a cave kind of a 3D projected kind of a room environment systems, okay, virtual environment systems were created for industry. Mostly industries have adapted this kind of technology and used it for different purposes, for their respective purposes. But basically, this is a virtual interactive environment. Okay, so this is like you're not sitting in front of a computer monitor. So instead of having a monitor as output device and keyboard and uh, mouse as an input to your computer, you interact with applications not on a monitor but a 3D projector room. Okay, so your 3 walls and 4 walls or 6 walls of your room is like a monitor screen that you are seeing looking around. So whenever you rotate your head, you can actually see in all different directions the objects or the environment that is being projected in front of you. So your head is tracked and your hands are tracked using these uh, trackers that you can see on the person in the image, right? So these are the markers which basically are used to track the hands movements and head movements. Okay, so this kind of a cave system was used, but this used to be like very costly and it is like more complex to set up and mostly used by industry, but nowhere near to the consumers. Okay, then we'll see like the timeline. If you see, it started in 1968 by this person we have just now talked about, Sutherland. He first tried to create a head-mounted display device, and then we had the first 1991 virtuality, the first mass-produced VR arcade device, and then Nintendo. I guess you people are familiar with the gaming console like Nintendo, right? Nintendo Wii, Nintendo 3DS. Okay, so those console makers actually created one gaming device which is basically Virtual Boy. Okay, so then we had in 2010 the first proper VR prototype, which is basically the Oculus Rift. Okay, and then as we evolved in 2014, Google also tried to create a very basic version of VR using cardboard. Okay, so you can actually, Google wanted people to explore VR. Even a common man like who are like the regular guys like we have phones, we daily use them, but you think like we can use our phones to experience VR, try VR is what Google thought, and they created this Google Cardboard, which allowed everyone who had mobile phone, smartphone, they can actually use this cardboard to put a phone inside this cardboard and experience VR. Okay, so we'll see that. And this actually made VR accessible and can be tried out by anyone. Okay, so then we have all these kind of VR gearboxes and other people actually starting to explore VR hardware. Okay, they started creating. And then you even have VR videos from YouTube. Okay, I don't know how many of you people might have tried, but I guess there is like hell number of videos now available on YouTube, which can be experienced in VR. Okay, they're called as 360 videos. Okay, and then we have the advanced version of VR devices now from 2016 to 2020 and all, like even in the next years, coming years, there are a lot of VR devices planned. And what are the devices that are currently in the market, which are very popular and very much adapted? We are going to see those also. Okay, next. Uh, Before going to understand all of these technologies, like what is AR, what is virtual reality, augmented, and mixed reality, let us just take a step and try to understand, step back and understand what is this thing, what are these devices, okay? And when I say these technologies, I'm terming them as the future is wearable. So what do you mean by wearable? The future of computing is wearable and it's 3D. So when we think of a computer, we generally think of a computer as a CPU, the main computing device, and then you have the output device, which is basically the monitor, the flat screen of 2D pixels. Okay, your screen is 2D, and your keyboard input, your input is basically the keyboard and mouse. That is what is the general idea of a computer is. Even if you transform your computer into a laptop, your laptop is also the same device like a desktop, which has a flat screen output device, and then you have the keyboard and the trackpad or mouse. So, but you can carry the computer anywhere in the form of laptop. But now, if I say we have gone forward, gone beyond, making the computer into a lap, converting the computer into a laptop, now into even a smartphone. Okay, so if I say your smartphone is basically a computer which is more powerful than a computer which was 8 years or 10 years old. So that will not be a surprise because the latest phones, the smartphones that we are actually carrying and using them daily, putting them in our pockets, and whenever we want, we are accessing them for all different purposes. These are phones which are basically nothing but mobile computers, okay, which have all the things that we have just now talked about what a computer constitutes. So the smartphone is also a computer which has the same motherboard and all the CPU, RAM, and all storage. It has the same output device as a screen, but the input is also the same screen which we are actually seeing as output as touch. So the screen touch itself is the input and the screen itself is the output. And the CPU is all laid out behind the screen with all the RAM, processor, storage, and all, right? And these devices, if you think of not just the hardware but also the software, the operating system that is inside the smartphones, and the applications that are there inside the smartphones are actually more powerful than the applications we used to have some 10-15 years ago. Okay, when we actually started in terms of the computing itself, the computer's history itself, we can easily see like where we are when we start from mainframes, right? The initial computers used to be like the size of the whole rooms or the stadium itself, right? So the mainframes used to be so big. Then with the advancements of integrated circuits and all, we have shrunk the computer thanks to transistor advancements. Computer from a big large scale kind of a room based kind of a mainframe computer to a desktop kind of computer, and now to the laptop and the mobile computer. Yes, so now we are easily able to relate computers to a phone. But then next we are going to see, and we already started, not just holding the computers in our hand but also wearing it on our hands and wristbands, your smartwatches, okay? And you're not just wearing it on your wrist but also on your head, which are basically called as head mounted displays. And those are basically the head mounted displays, which are what we are now terming them as VR devices, virtual reality devices, or mixed reality MR devices. Okay, we are going to see these, the future wearable computers. Okay, and these computers we are going to wear on our head, and We are going to wear them like a regular goggle, and those are termed as smart goggles now. Like the way we have smart watches, we are going to have smart goggles. Okay, so how these technologies are working and how we are going to build applications, how people are building applications for these technologies. So they're not just going to be wearable. I said they're also going to be 3D, because the applications that we have been building for the computers in the current generation, the past and the current generations are 2D and 3D, because the output device used to be 2D. Our output device used to be a monitor, which is a 2D screen. But now I said like future of computing is going to be 3D and it is wearable. Then if I say your screen, your computer is going to be wearable like a goggle, then where is the output device like a monitor? So you need an output device for your computer, right? If you have a desktop computer or a laptop, you have a monitor in front of you. You sit at a certain distance and you use the computer with the monitor in front of you. And now we have phones now, which are also computers, we have just now understood, and they are also like having screens. And so we put those screens in front of us, pull up from the pocket, and we use it in front of us. But now if I say you are having a computer which is a wearable like a goggle, then where is the monitor, the output device? The output device is going to be the screen that is in front of you, like on the goggle, on the glass itself. Like I have the glass, I have one. The glass itself will act as a monitor, the display. But how is it going to be? So this technology of VR and MR is all going to be immersive, holographic, interactive technologies, which are going to display graphics in the form of 3D. So we'll just go for further, instead of having just discussion kind of a thing and just having it imaginative. We'll see some videos relating to those also, and then we'll get to have clear idea how the what are the 3D, what are these technologies and why are we calling them as 3D, and how we are going to build applications for these 3D technologies. We'll come back to this slide. Okay, this slide has to be like again re-explained. Building 3D applications for 3D interactive technologies like AR, VR, and MR. So these technologies are going to be built, whose applications are going to be 3D. So till now we had all the applications on our computers in the form of 2D UI, 2D browsers, 2D PowerPoint presentation. Now the application that we have in front of us, any kind of applications, you take Excel sheet or all applications that are there in our operating system that we use in our company. Think of having Flipkart kind of application in 3D. Think of having Excel sheet kind of application in 3D, instead of displaying it on a 2D flat screen in the 2D form. So that is what I'm talking about, building 3D applications for 3D technologies like these, and developing using 3D development tools like game engine. So you want to build 3D applications, the immediate possible kind of tools that we can use to build 3D applications is the softwares that are used to develop games, the game engines, which allow us to build 3D games. We can use the same kind of development tools used by gaming in game studios like game engines, and those same tools and technologies can be used to build 3D applications. Instead of building them for the game, we are going to build for non-gaming applications. Okay, so popular game engines like Unity 3D and Unreal and all, CryEngine and all are mostly now being used not just to develop games but also build 3D applications for AR, VR, and MR devices. Okay, so whatever the videos that we're going to see, okay, for AR and MR and VR, those are all applications that we're going to see are built using these game engines. Okay, and then 3D development for all these platforms using 3D game engines to design and develop not just games but also non-gaming 3D applications. So let's start with augmented reality first. What is augmented reality? So there are two terms like reality and augmented. Reality is what we generally understand. Everything that is around us is reality. And the way we are interacting with real world around us is using real hands as input and real eyes as input, seeing it and then understanding objects, okay, interacting with them with hand and sensing them and all. Okay, but Augmenting is what? Augmenting the reality. The meaning of augment is extending, enhancing the reality. Augmenting real scene viewed by the user with virtual graphics generated by a computer. As you can see here, the camera of the phone is being seen through the display of the phone in the screen, and you can see the whole street through the camera. But along with the real environment that we can see through the camera, we are also projected with extra information using graphics on top of real environment. So at that particular floor, you can see some icon being displayed there on the top right, the a restaurant. So you have some restaurant on the third floor is being that kind of information is being represented and conveyed to the user of the phone using virtual graphic representations using icons and text and all. Okay, so that is like overlaying virtual information, virtual graphics on top of the real environment. So what does it do is basically it supplements the real world with the virtual computer generated objects that appear to coexist, that appear to coexist in the same space as the real world. So the way you have the real structures and the buildings and all that you can see through the camera, you have those objects in real, but at the same time the virtual objects are also attached to the real objects. And if you move the camera here and there also, you seem to it seems to us like the virtual object is also attached to the real object, so we can see them in video. Okay, so let's see one video of that, and this will be like interesting video of IKEA. Anyone heard about this thing? IKEA, it's basically a furniture company which has an app for their products. So people who want to purchase furnitures, we generally go to the showroom, we see the tables, furnitures and all, we try to touch and feel and explore. But we want to buy them, we get them, purchase them from the store and get it to the home. And once you get it in the house, maybe it will not fit or match with your room environment. The decision you have made at the store might not be sometimes proper. Once you get the furniture after purchase to your home, you place it in your room, it might not match with the environment, or you might not like the way you have done the purchase. So that kind of a problem for the consumer can be solved using an app that is given to the consumer in the form of a smartphone app or in a tablet or a phone. So use your phone to project a virtual graphic, basically 3D furniture, graphic furniture in real environment, and visualize in this kind of fashion. Say the same kind of IKEA example, one more that I have is this one. So what you see here is a real environment seen through the camera, and now you project a virtual 3D model of a sofa, furniture or whatever in front of you through the camera. So you scan the room environment, the floor, and then select a furniture object like this and place it in the environment. And it basically, now you see 3D object, the chair is coexisting with the environment that is the floor. So your floor is 3D and the object, the chair is also 3D. And it seems like the chair is looking like a real chair and placed on a real surface. Okay, so that is one thing. And now you see here, this is like a person who has done or gone through a real procedure of going to a store and purchasing the furniture. But now once he gets that furniture into the room, into your house, it might not fit. So this is another kind of a problem, or it might not actually match with the room environment. So that is another kind of a problem. So these all problems can be overcome with a AR based application in your phone. So that is what this video is trying to explain. So now a consumer is empowered to pre-visualize the product using AR even before going to the store and making the purchase. So this is like wise kind of a consumer choice that we have given to make better choices, and not just selecting the furniture, the 3D object. You can actually interact with that 3D object and change its color, texture, and you want to scale it or resize it or move it and adjust it wherever we want. Okay, so all that can be done just using your AR based phone app. And to make it more interesting, like I guess you people have heard about, you people have already experienced AR using a game called Pokemon. So I guess most of you are familiar with this game called Pokemon. So that is basically an AR based game, which uses Google Maps to actually uh, allow the players to place Pokemons and interact with Pokemon characters in real environments at a particular geographical areas. So that is one popular AR based game that everyone is familiar with. And these are like we have been seeing is non-gaming applications using AR. Okay, so the applications of AR can be a lot. We are going to see those videos, but the way we are going to experience them, the devices that we are going to use to experience AR is the mobile devices that we already have, the tablets that we already have, all the Android and iPhone devices are now actually already equipped. So you have your phone in your pocket now, you can actually use your phone to try an AR application wherever you're sitting. In fact, actually the Google search that we already have, we can search any 3D object within Google, and Google search already has this feature of AR. You can actually project, like say you can search for a tiger in Google search, and it allows us to project a virtual 3D tiger or any animal in front of you, like a dinosaur, in a room. Like wherever you're sitting in front of sofa or wherever, you can project a virtual graphic in front of you in your room using Google search. So that you people can try. And the other kind of interesting kind of VR applications that we can AR applications that we can see is uh, let's see one video which covers all the examples. Yes. So here is a simple application of AR. In fact, multiple actually. You can see a tab is being used to point towards a 2D floor plan, a civil engineering application. Like you can point your phone towards a 2D floor plan, and then you can project a virtual house which is being planned, which is not yet being constructed, but you can build a 3D version of that future house and help customer visualize their house even before it is getting constructed in 3D. You can make them visualize. So just seeing a 2D floor plan will not have clear idea of how the rooms are going to be, how the building structure is going to be from the exterior to the interior. But now you have your phone with the AR capabilities, which allows us to just point our tab to a 2D floor plan, 2D representation of the house, which will again immediately project a 3D version of that house. And it allows us to visualize how the future exterior of the house is going to be, or the interior of the house is going to be. Like you can see the both versions here now in this example. So this can be one interesting really a real estate kind of application which is already used in industries. And this is another kind of example applicability of cartoons, educational kind of AR based application, where we have kids, we provide them with cartoon books, story books. So while they can actually read stories using the cartoon books, we can also build an AR application which allows them to not just read the cartoon book, but also experience the characters in 3D using 3D AR application like this. So storytelling kind of a thing can be made even more interactive and even more experiential in the form of cartoon based AR application, cartoon books based AR application. This is another kind of AR applicability in packaging. So we have packages with a lot of detailed graphic on packages, right? So we want to make those kind of information in to the consumer in a more interesting and interactive way to give the consumer more detailed experience and give him more information, detailed information, which just a raw regular package could not give. So now you see this package is being used with an AR application which projects a more detailed kind of a character of the Barbie. Okay, so these are all like different AR applications for different purposes, different by different industries, like real estate and what we've seen is cartoon kind of educational kind of application, AR application, and advertising packaging kind of applicability of AR. So how does this AR work? Now that we have seen some examples of AR, let us see how this AR works. So what we generally have observed in these videos also is we use our smartphones to point to a real world scene. In that real world scene now, we select items from the AR applications from the given catalog of 3D objects and select the objects, like here in this case a chair, and then place it in the scene, placing the virtual object inside the real scene. Then once the object is placed, we can visualize it from all different angles, and we can also scale, rotate, move the objects, or change its texture or color. So we can give all that kind of customization options to the user, who will not just visualize it just by seeing it, but also interactively customizing it, customizing the product. Okay, so that is the possibilities that we can actually achieve using AR, using our existing devices like phones or tablets. Okay, let us see one more example of AR. I have set up examples here. But apart from phones and AR, how industry is actually using AR, and the other ways of using AR is this example, where you have a projector which is projecting graphics, and you have a real hardware like here, an engine, and you have a person who is getting trained to fix and learn how to fix an engine as complex as this using AR. So what we see is the real object and real environment, and you have a projector which is actually projecting graphics on top of real objects. So you see how the graphics are being projected on the engine, and these graphics are basically showing him the set of instructions in a sequential order of what to pick from which object, which location to which location. And if there is an error, as you can see, he is trying to put his hand in a wrong place, and then a beep is being indicated. So this is like an interactive training kind of a scenario using AR, but without phones and tablet. This is like using projector. So this kind of alternative AR based AR kind of technologies are being used in industries. Like example we have seen in automobile. And similar kind of example that we have is another one. That can be visualized through a phone or a tablet. And this is like showing graphics as indication to tell the next instruction of what to be put and what to be removed. So the series of steps of assembly is being indicated in this computer setup with the camera on top of the engine and the output monitor indicating the instructions graphically. This is another kind of a AR-based application, but using a computer instead of a phone or a tablet. As you can see, like the person is trying to go through the instructions without an expert, a senior engineer beside him to train him or instruct him. So that kind of problems of training can be solved using an AR-based application, using AR technology. So this is like training assembly simulation you can think of. Okay, let us next go to the development of AR basically. So now that we have understood what is AR and how AR applications have been built for different industries, and one thing that we have seen common in all these examples is we are seeing the real environments in front of us, but along with the real environments, we are able to project 3D graphic virtual objects on top of real environments. So that is where I mentioned like these technologies are 3D based kind of applications. So all these applications that we have seen for different industries, they are using the real environment and augmenting the real environment with some virtual graphic 3D graphics projected on top of it. And like a lot of, as I told you, Android devices already support AR. So Android actually allows developers to use AR core libraries like AR core APIs to build AR applications using AR core. And for iOS devices, we have Apple's AR kit that can be used to build AR applications. And apart from Apple and iOS devices, there's a common library like Euphoria Engine by PTC, which can be used to build AR applications for all the smartphones and tablets, be it Android or iOS or Tizen and all. And then we have open source, other kind of proprietary implementations of AR, like AR Toolkit, Wikitude, and Codin. So these are all different development tools that can be used to build AR applications for phones and tablets, be it an Android and iOS devices. Okay, next we'll move to the next technology, which is virtual reality, VR. So what is VR? As we've seen, AR is basically a technology which is augmenting the reality. This is basically a completely drastically different technology, which is not much similar to AR if you see it as it is, but this is virtual reality. What is virtual is, which is not real, but we are still saying virtual reality. So what does this do is, as you can see here, this is basically a head mounted display that we are supposed to wear on our eyes or our head, but not like a goggle which you can see through. But here this kind of headset is blocking our eyes. And the example devices of virtual realities, like we can see Samsung Gear VR and Google Cardboard we're going to see. So let us see what is virtual realities. It is basically a computer generated world with which users can interact. It's called virtual environment. So that is virtual environment which is being computer generated, and we can interact in that environment. We can go into that environment and we can interact with objects in that environment. The interaction can vary from looking around to interactively modifying the virtual objects. So this is like the technology which has two different versions. As we can see here, we have the low end version of VR and we have the high end version of VR. So this is the device that we are seeing is the Google Cardboard and Samsung Gear VR are basically the low end version of VR. And the high end version of VR is basically Oculus Rift and HTC Vive we are going to see. So what is low end version of VR is the mobile version. So the tablets and phones that we have, we can use our phones to experience VR. So we don't need to have a computer to experience VR. You want to experience VR, we already have the phones with us. The phones that we have is more than enough to experience VR. Okay, so that is where this cardboard and Samsung Gear VR devices come, which are basically the empty blocks, empty devices boxes, basically, but it allows us to put our phone inside the device and then experience VR. Like you can see here, the cardboard is unfolded, the phone is put inside, and then the cardboard is again packed, and you can experience VR using that. The high-end version of VR is basically these devices, which are a more complicated devices, okay, with a lot of detailed precision kind of a tracking for head movements also, and hand movements using hand controllers, as you can see. And there are some sensors which are like externally put to track these headsets and the hand controllers. So these are the devices, high-end VR devices, which can be connected, which are connected to the PC, and the PC need to be a bit more reasonably powerful with a proper graphics card. And these devices, once connected to the PC, applications run in your PC, but the output is shown through the head-mounted display. Okay, so apart from these devices, we have even Microsoft actually building mixed reality, Windows mixed reality platform, which allow a lot of other vendors to actually build their own headsets actually. So the software solution is basically created by Microsoft, and the hardware is all built using different hardware vendors like Acer, Asus, and Dell, and HP, and Lenovo. A lot of other manufacturers are building head-mounted displays, virtual reality head-mounted displays for Windows mixed reality platform. And the others which we already have seen is HTC Vive and Oculus, who are having their own head-mounted display hardware plus also their own software. Let us see one example of what the VR is. Just see the video and we'll understand what is happening in VR. So this is basically a game example which is basically built for VR. So we play this game in VR headset. Okay, we wear the device and we are like inside the game. So how is the experience inside the game? This video actually tries to show us. So now you see here, you have the VR headset worn and you have the hand controllers in your hand. So your head is being tracked, your hands are being tracked. So the way you move your head around and the way you move your hands naturally, like in real life, real world, how we move our heads and hands looking around. You want to see some object behind you, you can turn around and see. The same way in the VR also, once you wear the headset, like you are in this game world now, and you want to turn your head and look behind what is there, is some robot coming or not, you can turn and you can see there's some object and you can interact with them. So this is like the natural way of interaction that we generally do in real life, head movements and hand movements. The same thing is being simulated within the game using VR devices, using VR headset and VR hand controllers. So this, using this kind of a tracking technology within VR, this is one example game which allows us to play the game with our hands, looking around, navigating from one place to another. You see how the person is interacting with his hand and head. So this is like gaming, which is immersive gaming, which is called as immersive gaming. And there are like a lot of games being built now, and people who experience VR can actually see how interesting this kind of example games are. Okay, so this is one VR based game, entertainment kind of applicability. Let us see one applicability which is like this one. So this is an industrial applicability where there is this VR training scenario. This is an engine, car engine, which is being played out in the form of interactive animation, engine working. And if there is an error, like you can see a person in the virtual world, with the VR headset, his head is being tracked, her hands are being tracked. Using this kind of a tracking, which is precise tracking, she is able to interact with virtual objects, pick objects, place objects, perform precise kind of a debugging that we generally do with real engine with our real hands. The same thing is being simulated within VR, but no real objects. Everything is virtual objects, virtual engine being simulated, and hands are also, interactions are also done virtually. This is real industrial applicability of VR. So how you can see how VR is actually transforming the way we actually simulate reality in a virtual world. So we might think like why a person might actually wear a headset which will block their eyes. But think of scenario like this, which allows us to, in reality, if you want to debug this kind of a complex engine, we might, as a trainer, as a learner, try to learn about it and fix it by taking real engine into our hands and try to fix. But we think we can actually fix or work in this kind of environment is impossible, because if we fail, the engine might break and it might cost a lot of money to fix it or replace it and do something with it. So that kind of a complex kind of a scenarios can be overcome with the same kind of a training scenario being simulated within VR using not real but virtual objects, and the same interactions that we generally do in reality can also be simulated as it is in virtual reality. That is what VR enables us to achieve. This is one example of VR. Let's see one more example of VR, which is the training scenario of crane heavy machinery control. Like example, a crane. So we have these kind of a lot of devices, instruments or machines which are too complex to handle or control. But think of having this kind of application which allows us to learn about the complete machinery, how to handle it, how to control it, everything within VR. Like you can see, this person is actually wearing HTC Vive device and using the head and hand tracking, he is able to use a VR application which is training him to control a crane or learn how to control a crane and operate it. So this is the example which is giving us idea about how VR is being implemented or used in different industrial scenarios. And this is another example of medical training scenario where a person can be trained to perform or learn about complex procedures, be it more medical equipment related or medical surgery, basic surgery kind of related training scenarios can be built using the VR technology. So every time we talk about VR, what we generally and mostly see is the simulation of reality in a virtual form, and then entering into the virtual simulated environment and then performing things that we generally do in reality, the same kind of interactions we perform within virtual reality. Why do we need to do, why are we doing, why are we made to do like this is to do things or learn things which are not possible in reality but can be made possible in virtual reality. That is what VR is enabling us to achieve. And how does VR work? So let us see like how VR works. So VR is basically, we don't need to do any kind of a scanning of the room or something, but we just need to wear the headset and have some space around us, at least like 10 meters to 20 meters. Now that we have, because these are all devices that we have just now talked about is tether devices which are connected to the PC. But thanks to the advancements of technology, now we have Oculus device, the latest version of Oculus is Oculus Quest 2, which allows us to actually have VR without any cables connected to the PC. Okay, so this is like wireless VR. So you can actually move around in the room, between the rooms by wearing the headset, but still you don't bump into any objects. Okay, so this is like untethered kind of a wireless VR, which is now possible. So the limitation of area restriction apply only for the high-end VR devices like this, but mobile VR kind of devices like Oculus Quest 2 and all don't require this kind of area restrictions. So we create a virtual environment and we go into the virtual environment by wearing a VR device and having controllers in our hand. These head-mounted display and hand controllers allow us to interactively experience the virtual world, pick objects, walk inside the environment, look around. All that natural gestures that we generally do in real life can be performed within VR worlds also using VR technology. So how does VR development actually happen? Is the same like AR, which is again, we have VR devices that we have seen. They have their own proprietary SDKs, libraries. So similarly, we have Oculus has its own Oculus SDK for their own Oculus devices. HTC has its own Vive developer kit for HTC devices. But we have Steam SDK, Steam library, Steam platform, which allows us to use its SDK to build VR applications for any of these VR devices, be it Microsoft mixed reality devices or HTC Vive or Oculus. One platform that allows us to create one particular application and publish it to any of the VR devices. So that is the specialty of Steam SDK. So build once and publish it to any of the major VR hardware devices. Execute anywhere like that. So that kind of a solution is also available in the current markets. Then let us see what is the next technology apart from AR and VR, which we are supposed to talk about, is mixed reality. So what is mixed reality? I said AR, the combination of AR and VR is what MR is. It is basically a combination of both virtual reality and augmented reality that creates a new environment where both physical and digital objects coexist and interact in real time. We would also say like MR is basically the advanced version of AR with some VR features also added into it. So we know AR is basically augmenting the reality. So you have real objects in real environment. You also have virtual objects and enhance the reality, augmenting the reality. That is what MR also does. But the thing that MR does is, one more thing that MR does is, it also acts as a head-mounted display device. So the device, the MR device that we are going to talk about is the device which we are going to wear like a VR device onto our goggle, onto our eyes. But this time, unlike VR device which blocks our eyes, these MR devices are actually like goggles, glasses, okay, transparent glasses, which allow us to see the world in front of us, but at the same time project graphics, virtual graphics also on top of real environments through these glasses. Okay, so there are pico projectors beside these glasses which allow us to project graphics on top of the mirror glasses, sorry, and then allows us to see real objects also and virtual objects also. So let us see one example to understand how mixed reality actually works. Okay, so yes, this is one example of mixed reality headset. And what is this mixed reality headset example in this video we are seeing is Microsoft HoloLens. So you see the person is actually wearing the VR headset, sorry, MR headset, mixed reality headset, which is basically a transparent see-through glass which acts as a display. And you can see the display is actually, I told, will be on the glass. But for us, through our eyes, if we see wearing the headset through the glass, it seems like the object is actually placed in front of us on a table or something. The virtual graphic is placed in front of us in real environment. Like it's on top of the floor you are seeing or the table in front of you. So you can float the objects or place the objects in front of you in real world like a virtual hologram. We use the term called hologram. So these things can be termed as holograms. And these are like virtual holograms floating in front of us. And not just seeing these kind of holograms through the HoloLens headset, we can actually interact with them using hand. So these devices are inbuilt with tracking sensors and cameras actually, and these cameras allow us to do hand tracking also. So you can use your hand to interact with the objects in front of the virtual objects in front of you. As you can see, these people are using hands to interact with. As we have the camera technology which allows us to do face tracking, similarly we have already got hand tracking technologies, and that hand tracking technology is inbuilt within these devices. So this is a computer which is basically running full-fledged Windows 10, but customized for a HoloLens device. And now this computer is like any mobile device, but except this output is not the screen in front of you, but output is the goggle with pico projector projecting on the top of the glass in front of your eyes. And the input is basically not any keyboard or touch screen, but your hand tracking. Okay, so your fingers are the input to your wearable computer. So you can see how this person is seeing the real environment. Like here he is trying to debug an electronic board. Okay, so while he is debugging, the application, the mixed reality application is trying to project virtual holographic icons interface, UI interface in front of him and providing him with a lot of options to do the troubleshooting. But if he has any problem, he has options to even call the other person. And you can see here the Skype application that we generally have on our 2D screen as a 2D Skype application. Think of that same application now is projected in front of you like a 3D hologram screen. So this way, even a video call is made within HoloLens headset as a hologram, and issues are being resolved. Examples of debugging or training scenarios or troubleshooting or interactive kind of discussions like these. Collaboratively planning. One question you might be having when we see these kind of scenarios is, here in this example, as we stop this slide, all of these guys are wearing transparent goggle based HoloLens headset, and each of these headset is a computer, as I've told, and each of those guys are able to see the machine in front of them, but all of them are seeing the same graphic. All of them are seeing the same graphic application at the same time. So this is like the way we are now having chat or the video call live. Like I can see the slides, you can see the slides, the screen, same screen I'm trying to share. Or the other more better example can be the way you generally play PUBG or any kind of a multiplayer games. So you are in that same virtual world of the game, and the others are also joined in the same virtual world. So whatever you are doing in the game, all actions of your are being broadcast in real time to others in the game, the other players also. Same way, so that is like the wireless kind of a multiplayer scenario of a 3D game. This is a wireless kind of a multiplayer scenario of a 3D application instead of a game. So this is the kind of a multiplayer, multi-user kind of a interactive scenario, 3D interactive application scenario. As we can see how these technologies are being built to the scale of a headset, and how using different sensor technologies and projection technologies we are able to transform computer from being a mainframe to a desktop to a laptop to a phone to a wearable goggle. Seamless computing is what we call it as wearable computing. And this is now possible through the MR headsets. This is mixed reality. Examples of mixed reality that are already in the market is like Microsoft HoloLens. Its version 2 is also already in the market. And you have Meta 2 and all. And Magic Leap is another device which is more shrinking in terms of size and looks more like goggle. And apart from these devices now, already Apple is planning to build their own AR based kind of a goggle, and Google and other kind of big players are already into these technologies, not just into VR but also into AR and MR. Okay, so this is one example that we have seen. I guess we'll see one more if we can, to understand the mixed reality platform. Okay. Okay, so let's see. Once we have seen these applicable, these kind of videos, let's see like the other kind of a possible applications of these technologies. Okay, of AR, VR, and MR based. Like you can see, games are by default the very first scenario where we can apply these technologies. So gaming is the industry which adapts this technology from the very beginning. And there's like big market of AR based kind of a games. There are big expanding market of VR based games. Maybe not MR, not yet, but AR, VR technologies are being uh, extensively being adapted by gaming industry. And then there's an automotive industries also. They are using the virtual kind of a projection based kind of a what do you say, deck for the computer for the automobile vehicles. Okay, so um, this is one automotive example, and within the vehicle kind of a info system within the car. So that is using AR kind of a technology within automobiles. And then engineering and design kind of applicabilities of AR, VR are, we have seen extensively being used. And retail and all, like as we have seen, IKEA is one example. Similarly, other kind of examples by other industries are being adapted. And then you have marketing and advertising, like we have seen packaging or selling of product. Okay, so that is another kind of applicability of uh, these technologies. And we have VR extensively used, like we can see in malls. We have VR zones now, which allow us to wear the VR device and experience a roller coaster kind of a virtual roller coaster kind of experiences. And VR interactive exhibitions are also already existing examples, especially during this kind of a pandemic time. Any art kind of exhibitions need to be conducted. It is impossible now for the people to go to a location, but people are making art kind of exhibitions possible through VR. And then entertainment, where you have VR technology is being used in movie making, movie virtual production, generally called as virtual production. And movie industries are already adapting VR technologies. Okay, and AR technologies also to build or make movies. Like example, The Lion King, which is like completely graphically based virtual movie, and that movie making is actually done using virtual production. That is basically using VR and AR technologies. So the making of the movies are done using these technologies, and the whole process is called as virtual production. And then we have training scenarios like flight simulations and battlefield simulations for soldiers using VR technologies, using VR head mounted display devices. And we have surgery simulations, as we have seen by example, and then other medical healthcare kind of applicabilities of phobia treatments are made possible. And using research, they have actually found VR to be even more effective in treating these kind of uh, phobia treatments, for phobia issues, health issues can be overcome. Fear kind of a thing can be overcome using VR based kind of solutions. Robotic kind of surgery, skill training, examples of VR based and AR based kind of examples. Like virtual tourism and manufacturing training kind of a scenario. Okay, these are all also some examples. So these are all like different industrial applicabilities of these technologies, and how these technologies are actually building since years, and how their market share and how they are actually entering into consumers, and people are trying to adapt these technologies and realize the importance of these technologies. Like we can see here, the market share of AR VR technologies is expected, currently it is 30 kind of a $1 billion, but by 2024, within 3 years, 4 years, it is expected to reach to $300 billion. That is like 10 times within 3 years, 30 to 300. That is what is being forecast. That is the kind of adaptation the consumers are actually making, getting used to, getting exposed to these technologies of AR, VR. We might not realize, but we already are very much exposed to AR technologies with Pokemon kind of a game, which is like become popular worldwide. And using VR devices like latest kind of Oculus Quest kind of devices, which are big, which have become even more cheaper now, to the level of even 20,000 to 30,000. We can actually get a VR device, and we can experience VR device like any other game console. So people have a lot of market for game, like we can see game market, especially game console market. In a similar way, we have now, to the same price point, we have VR devices which can be easily purchased, and VR is actually entering into every household now, thanks to Oculus Quest kind of a devices, and adaptation of VR is expanding very rapidly. And then we can see adaptation of these technologies in terms of industries also. Gaming is always like video games have been in forefront in adapting these technologies and advancing these technologies. Other sectors like healthcare, engineering, or even the live streaming, live events are being uh, using these technologies. Okay, so especially live events have become more common now using VR devices. Virtual kind of events are being organized, and engineering, healthcare, and all entertainment, movies, like immersive movies are also one best example that movie industry is actually experiencing. Um, like the way we generally see movies and see stories in front of us in theater, which is a flat screen, on your computers, which is flat screen. But think of seeing the movie by being inside the movie. So that is what the movie industry is actually exploring, where they are trying to make movies which are VR based movies, which allow us to enter into the virtual world, enter into a movie world, and you see a movie not in front of you as a flat screen rectangle being projected like a window. You don't see the movie in a window, but you see movie around you. So you think of movie happening around you. So that is what is immersive movie kind of a storytelling movie industry is coming up with. And real estate and retail, military and education, all of these sectors are very much actively exploring these technologies. And coming to adaptation by organizations, we can see in terms of retail, and I guess we have already tried out, some of you might have tried out AR lens cart. You want to try goggles like glasses, eyeglasses. Lens cart actually has that kind of option to sit in front of a computer or laptop, and then or in front of a phone to wear and try out different goggles. So using the camera, it allows us to explore or try out different goggles on our eyes. So that is one very interesting kind of applicability of lens cart. So like that, we have a lot of other applicabilities by every industry, like building not just one particular segment based kind of applications throughout different industries. Like IT companies are using these technologies to build custom solutions for healthcare industries or engineering, mechanical kind of automobile industries, okay, or any other sports based kind of applicabilities. So they're exploring all that, and these kind of companies are expecting 3D developers, basically AR, VR, and MR developers, and they want these developers to build not any kind of regular software applications, but it's more specifically 3D AR based applications, VR based applications, and MR based applications. And there are like a lot of job roles they have been expecting. Like they now currently like job roles, like you have people expecting Unity developers, game engine developers, or simulation engineers, AR VR designers, architects, AR VR creative leads. So these are all like different roles that are being that have become more common in these industries, expecting AR, VR, and MR content developers, be it design kind of roles or artistic kind of roles or engineering programmer kind of roles. So these hardware technologies have become so common now. Every industry is adapting and building AR, VR based, MR based applications instead of having, because now we know software industry, software development, every software that we develop for the web, for the desktop, or the computers, or the mobiles, every application we build is all 2D. That's what I said. Like the computer of the future is already no more 2D but 3D. Now people are going to hold computers not in the hand, they're going to wear computers as a goggle. And now they're going to do Flipkart kind of a interaction, a Flipkart kind of application in a wearable headsets using holographic projections of applications. So that is where 3D application development has become more of an important thing, because we are now transitioning from 2D kind of a computer to a 3D kind of a computer, and the applications that are going to be built for them is supposed to be redesigned and rebuilt from 2D kind of a interfacing to 3D kind of a interfacing applications. That is where we are having these kind of a roles of AR developers, designers, VR based developers, designers, and MR based developers and designers very much in demand, thanks to these technologies of AR, VR, and MR. Okay, so this is what is the webinar about. What is AR, VR, and MR technologies, what these technologies are, and how these technologies are transforming the future of computing, and how these technologies are going to be the future of computers actually, and how people are going to use technologies in a completely drastically different ways, like the way we haven't even realized thought we were actually using computers on a desktop or like a laptop. but we never realized we already actually started using computer as a smartphone that we put in our pockets. So without we being realizing, we might start to use wearable computer like wearable goggles without even realizing it. So the next replacement of computer from desktop to how it transformed into a phone, and now it is going to be the transformation from phone to wearable goggle. And we need to be ready and understand what these technologies and get ourselves equipped with these technologies. So this is what is a webinar about, and I hope you people have gained some insights into what these technologies are and how they work, and how we can build applications and for these kind of platforms, and how these technologies are being adapted by industries, and how it is entering into our lives. I guess this information was useful for everyone. Thank you, and thank you one and all. Yes, Rishi, can we have any Q&A questions?
Yes, sir. Now we shall start the Q&A session. For our first question, we got that: are there any existing AR applications to enhance newspaper reading experience?
AR-based applications. I guess we
For
have,
reading
yeah. So news reading is basically that we generally do using newspaper, and it's all like text-based kind of a reading that we generally do. But we have already AR being used in newspapers, maybe not for the articles, but for the advertisements. So the ads that we see in our newspapers, these advertising companies are already using AR technology, which is allowing the consumer to use their phone and point their phone towards the advertisement in the paper. So whatever the information they can maximum give in a newspaper ad, that every ad company wants to give detailed information about the product. So that is what they do in a newspaper ad also. But beyond what we see, beyond the information that we see in a newspaper ad, we want to give extra information and also make the user interact with the advertisement. That is where the AR based ad applications are actually coming, and there are a lot of applications already in the market which use AR technology for uh, newspaper based ads. Yes.
Okay, sir. Are there any side effects for our eyes and ears due to these technologies, and also
Yes.
advantages and disadvantages?
While these technologies are basically being developed since 60s until now, there was always this question of how this technology is going to be used, and why people want to wear a headset, and why they want to actually disconnect from reality. And when you wear a headset and your head is being tracked, you seem like you are immersed in that world. But when you are immersed, you have this kind of a tracking which allows us to look around in the world, but those worlds that we are seeing in front of us, the virtual world, they are being rendered in front of our eyes at 60 to 70 frames per second, or basically they have put the standard to 90 frames per second. So previously it used to be very less in terms of frame rate. So that is the reason where we used to actually have nausea kind of a effect, head pain and all. But now, thanks to the advancement of technology in terms of processing speed and memory, we are able to now achieve more than 90 frames per second to even 120 frames per second. So when you wear the headset and you are immersed into the graphic world, the graphics are displayed in front of your eyes at higher frame rates, and the tracking of the sensors is also very precise. Okay, so because of the tracking and the speed of frame rate, we are nowhere, we don't feel any kind of a nausea kind of effect now. So there are no health effects, especially now. That is the reason why we are able to see consumer products already in the market. So these consumer products are already tested for the consumers and then released into the market. So we don't have any kind of a health problems now relating to these technologies. They are
Okay,
already tried and tested. Yeah.
yes. Sir, for the next question, you told something about virtual reality boxes, but how do
Yes.
they work, sir? In other words, how do they enable us to perceive virtual object as real?
So as we have seen in the videos, maybe I can show the video again. Okay, so what we have here in this video is, like you can see the demo here. You can see the person actually in a VR world. She is able to look around using the head, and she can see all the different directions of the environment in the room, okay, in the virtual room. And the way we are actually in this current room, looking our head, looking through our head, like in the real room, in the same way we create a virtual room, and the head movement allows, tracking allows us to see through the virtual environment. But also the hands are being tracked, so hand tracking is also very precise. There is no jerk at all. There's no jerk in head tracking and hand tracking. Now that we are immersively looking around and inside, being inside the virtual world, the only thing we can do is, instead of just seeing, we want to interact with objects. We want to pick objects. Like I can pick a bottle in front of my in front of me, like I can pick it with my hand, with my fingers. The same way, the same precise kind of experience we want to have, similar kind of a gesture, natural gesture kind of interactions we want to have. That is what these trackers are able to achieve. Like in this case, HTC Vive device is what she is wearing, and she is interacting with these kind of a virtual components of this engine, and she is able to pick one plate and put it on the top of the engine. Every component she is able to precisely go to the place, pick it with her hand, and then take it to other place and place it there by releasing the button on the controller. So that kind of a interactive immersive experience is what VR is able to give us. Now think of the same scenario in real life. Now in real life, we have this engine in front of you which is broken. Now you are supposed to fix it. So how do you fix it is, you use our natural gestures to go pick that item, and then we maybe that object might be very heavy. You might require two people to actually pick that plate. Okay, that's a metal plate which will be very heavy. So she might not pick it. She might require other person. But you see that kind of a simple scenario. Real objects provide us a lot of constraint in terms of working environment. But think of simulating the same complex situation in VR. This will simplify the whole complexity and reduce or completely remove that kind of a complexity that real environment actually provides. That is what VR is able to achieve. So this is one example that VR is able to allow us to do all that. So all that information relating to the equipment is also, you can see, is being projected in the form of holographic UI. So that kind of information in reality we don't get to see. Maybe you will have a booklet relating to that engine to read the manual about that engine, and then you try to get some information about it. And or if you want to get more information, you might go to an expert or an engineer, a senior who might be actually helping you to fix it. So that is another kind of scenario. But the real scenario is actually more detailed and more complex, and it is hard to actually perform these kind of operations in real scenarios. That is where now you can see all that information. You don't need any expert. You have the UI here displaying all the information in detail about these components and engine related parts and all. And that objects which might seem heavy, but you can actually easily pick those virtual objects and place it. So that kind of a physical constraints are also removed. And tracking and all is like more precise the way you have it in real life. So all these kind of add up to the advantages of VR when compared with real life scenarios. Yes, yes. Anything? What is the next one?
Sir,
So this
what are the
is
disadvantages for these technologies?
the only disadvantage we have been, the major disadvantage for this technology till now, for not being adapted, even if it was imagined long back, is the speed of execution. Like the way the graphics are rendered in front of you, and your hand tracking, all of that kind of a sensor trackings for your hands and for your head, for easy movement here and there in VR, within VR. So all that used to be restricted because of the speed of the hardware, the processing speed of your computer. Okay, so we want to render that kind of a reasonably looking 3D graphics. We could not do that about 10 years back. Graphics advancement actually happened only recently about. Okay, the processing speed also actually happened very recently. So that is the reason why we could not see easy adaptation of these technologies about 10 years ago. But now, since last 10 years, these technologies have become common thanks to advancement of sensor technology, advancement of display technologies, advancement of 3D technologies, graphic technologies, okay, and advancement of computer vision, actually marker-based tracking kind of technologies, which are now made it possible. Yes.
Yes, sir. Now it's time for us to end the session. Before
Sure.
that, I would like to give a reminder for the upcoming session. Tomorrow we have a session common for all the branches. Dr. Lata Christie will be the speaker, and she'll be speaking on the topic artificial intelligence. Thank you again, sir, for taking the time to share your valuable knowledge with us all. I thank everyone for participating and attending this session. Let us all come together tomorrow for the next session.
Yes, thank you, Rishi, and thank you everyone for participating in this webinar. And I hope this is very much informative for you people, and hope it has given some insights into what these technologies are. Thank you. Thank you, everyone.